Hello, ladies and gentlemen. I want to start off by thanking you for joining me as we continue our look at the 2010 Manitoba Math Contest. We're looking at question 3 in this video. We've already seen questions 1 and 2. Those videos are already up, and we're going to take a look at question 3 now. So 3a. At what points does the circle with equation x squared plus y squared equals 3 intersect the parabola with equation y equals 2x squared? Alright, so this isn't so bad. We can just, we've got the equation for y in terms of x. We can plug that in, and we can start rearranging and solving. Okay, now in general, I would expect, I think this is going to end up being a quartic, and we should expect for solutions in general, imagine just a circle and a parabola. 1, 2, 3, 4. At most, you're going to have 4 solutions there, so we should be expecting 4 here. So we want y equals 2x squared, and x squared plus y squared is equal to 3. So I'm just going to take this and plug this in here. X squared plus 2x squared squared is 3. X squared plus 4x to the 4 is equal to 3. I can rearrange this. Make it minus 3 equals 0. Okay, well you might say, it's a quartic polynomial. I don't know how to solve this. Well, one, there's a quartic formula, but geez, do not memorize that. It is huge, it is monstrous. But it is possible to do these by roots. But here's a trick, and if you haven't seen it before, I think it's an excellent trick. This isn't just any old quartic. Okay, it's not one you see in the wild very often. In the wild, you have a whole lot of stuff, but notice that we just have x to the 4 and x squared. So what we're going to do is we're going to change this quartic into a quadratic. Okay, let me show you how. So I'm going to, we need another variable, so let's say let z equal x squared. Well, then we're really solving x to the 4 really just becomes z to the 2. And so this is now what we're solving. Okay. Now, I'm never very good at solving the quadratics when you have a constant up in the front, so I'm just going to go with quadratic formula, because it always works. So negative b plus or minus b squared minus 4ac all over 2a. So it'll be negative 1 plus or minus 16 times 3 is 48. The negative signs turn into pluses, so this is going to be 49, and that's quite nice. There's going to be an 8 here. So negative 1 plus or minus 7 all over 8. Negative 1 minus 7 is negative 8 over 8 is 1. And other than that, we can get 6 over 8. So that's our z here. So z is either negative 1 or 6 over 8. But z is x squared, so x squared is either negative 1 or 6 over 8. And now we can just square root both sides and solve for x. But x squared being equal to negative 1, you will never ever have a square be a negative number. So we'll only have x squared is 6 over 8. So I'm guessing that, and this circle is centered at the origin. If we draw a slightly better picture, we'll find that there are only going to be 2 intersection points here. But having someone come along and just say, here's a parabola, here's a circle, you should expect 4 intersection points just in general. Okay? But you can have none, you can have 1, you can have 3, well that's really rare. And then in this case we have 2. And they're both going to be given by these x's here. So x is going to be negative the square root here. So negative root 6. Let's change the 6 over 8 to 3 over 4. So it'll be negative root 3 over 4. Or root 3 and not over 4 over 2. And that's a nice number. Makes me think of sine and cosine and things like that. But now we need our y values. Well, y is 2x squared. And I already know what x squared is, so it's going to be 2 times 3/4 or 6/4 or 3/2. And we could double check that y squared plus x squared is in fact 3. We don't need to, but we could check that. 9 over 4 plus 3 over 4 is going to be 12 over 4, which is 3. But the point is, and we just wanted the points, right? At what points? Yeah. So the point is, we got our x and our y. We just have to write it up. The points of intersection, POI, are negative root 3 over 2, 3 over 2, and root 3 over 2, 3 over 2. Notice how symmetric this is about the y-axis. Okay, now I don't think that was it for the question. Yeah, we still have 3b to deal with. So, what does 3b say? The three lines, whose equations are y equals x minus 7, x plus y equals 3, so there we have it in sort of standard or general form, and y equals kx plus 8, pass through a common point. Find the value of k. All right. Well, the first two lines, we know them. We know them fully. We know everything they're talking about. They're only going to intersect in one point. And so we just need to make sure, we need to calculate what that point is. And then we know it has to be on the other line. Plug it in, solve for k. So y equals x minus 7. And x plus y equals, 4 or something? 3. So let's find their intersection. So that'd be x plus x minus 7 equals 3, right? We just substitute the y value in, just like we did in the last one. And we'll get 2x minus 7 is 3. It doesn't take too long to see x is going to be 5. So the point of intersection here is going to be 5, and then 5 minus 7 is negative 2. Now we can check 5 and negative 2. Yeah, that adds up to 3. So 5 and negative 2 is on the line y equals kx plus 8. So negative 2 is k times 5 plus 8. I'll bring the 8 over to the other side. Negative 10 is k times 5. K is going to be negative 2. That was simpler than the A part. I was expecting it. Usually I expect B to take a little longer than A, but no, that was quite quick. So that finishes up question number 3, and in the next video, of course, question number 4. Join me for that next time.